My name is Marius Kopi. I'm going to be presenting, and sorry, not presenting, part of the presentation today and looking over the chat besides my colleague, Robert Ramiro. As a short introduction, I'm a mechanical engineer. I'm a certified machinery safety expert, specialized consultant with WSPS for 5 years now. Time is passing. 10 years experience in the industry and renewable energy industry and construction sector. So lots of knowledge on that front as well. And before jumping into the presentation, I gotta let you know, we skipped the slides about Microsoft Teams introduction because I think everybody is fair to say knowledgeable about Microsoft Teams after COVID and everything, that we had to stay in the virtual environment for a while. The chat will be open to everybody, so please be respectful and patient with everybody's level of knowledge and understanding. If you would like to ask us a question, just put it in, add it in the chat or raise your hand, and we'll try to take them as they come in. If there is a short answer to it, then we'll address it as the questions come in. But if it's a longer topic, we'll park it for the end of the meeting, or we'll send a message to the rest of the participants at the end of the meeting as an email with a thank you email as well. Moving forward in our presentation, we have a disclaimer about the information that is presented, because we have to say things are protected and copyrighted. And also I want to let you know about the demographic survey that we have, and we actually work in collaboration with the Ministry of Labor to collect some information on behalf of our funder, the Ministry of Labor. This is optional, but I want to let you know this is all done with no transmission of details or private information to the ministry. So everything is going to be anonymous and secure. The information collected is our demographic questions. We're going to have this link presented to you in the chat, and the function number that you see on the screen is going to be like an access code. And you can also scan the QR code that you see on the screen. Before moving forward, I just wanted to introduce my colleague, Robert Ramiro, who is a professional engineer and holds designations as Certified Health and Safety Consultant. He's a certified machinery safety expert, a functional safety engineer, and he comes with more than 30 years of experience in manufacturing, more than 14 years of experience in pre-start health and safety reviews or different types of safety consulting services. He's one of our leads in machine and robotic safety department, and he also stands on several committees, Canadian standards committees, like the CSA Z434 Industrial Robot and Robot Systems, like the CSA Z460 Control of Hazardous Energy and Other Methods, that's the lockout tagout standard, ISO 3691, safety of powered industrial trucks, and so on. So he comes with lots of knowledge, lots of experience, and a fair share of passion and implication into the CSA standards. So without further ado, I would like to give the control to my colleague Rob. And I hope I didn't make this introduction to WWF type, World Wildlife Fund.
I've got control. Thank you.
And he's going to start the presentation right now. Thank you so much, everyone.
Great. Thanks, Marius. Hi, everyone. As Marius mentioned, my name is Rob Vomero. I probably know some of you, or our paths have crossed in the past. Thank you very much for attending this Safety Connection. I know you're all busy, but we do appreciate your attendance. WSPS does these safety connections as another means of connecting with workplaces. And for today's session, as Marius mentioned, I'm very happy to announce that as of May 1st of this year, the new CSA Z434 2026 Industrial Robotic Standard has been published. With the release of this standard, Canada joins the US and numerous other countries who are members of ISO, which is the International Organization for Standardization, in nationally adopting the international version of ISO 10218 2025 parts 1 and 2, which we're going to talk more about later. So, of course, we get individuals with all kinds of different robotics experience attending these sessions. So for those of you that are newer to these standards and robotics in general, the first thing I'm going to do, which is the first item on the agenda, is to provide a quick general overview of the CSA Z434 and ISO 10218 standards, including talking about things like just review how they're related, which versions are current, which versions are withdrawn, and a brief explanation of the different parts. Now, for those of you that are more experienced in robotics and have used these standards in the past, please consider this a refresher. We're going to get into the sort of the meat or the more detailed information of the session in the second agenda item, where I try to highlight some of the changes in the new CSA Z434. A couple of other things just to level set everyone. There's no way I'm going to be able to cover everything, of course, in this hour and a half that we have together. But one thing you will notice as I'm going through and highlighting the changes, I will be referencing both part 1 and part 2 of the standard and sort of jumping back and forth between them. And the reason for this is that there's similar information that is applicable both to the robot itself as well as robot applications. So we have these sort of equivalent or similar clauses both in part 1 and part 2. Again, correlating the two is important for understanding the overall standard. So you'll notice I'll be mentioning parts 1 and parts 2 quite frequently. I'm going to review what part 1 and part 2 are about in the next few slides, but I wanted to make sure I just mentioned that at the outset. Okay, so let's move forward. So let's start off with a quick poll, which I believe Jessica is going to launch in the background. So how would you rate your level of knowledge of robot safety standards, either ISO 10218 or CSA Z434? So would you say that you're very knowledgeable, somewhat knowledgeable, little knowledge, or no knowledge? And we just want to get a sense of who's attending the session, which is the reason why we asked this question. So if you could take a minute and respond to the poll. Okay, so there's a good number of people that are somewhat knowledgeable. We have a good number also that are very knowledgeable. And of course, the group is spread out through the entire spectrum. We have a fair number that have little knowledge and a few of you that have no knowledge, which is all totally fine. I hope there's going to be something for everyone in this session. We're going to start off, like I mentioned, fairly general, and then we're going to get into some details on what's new in the new Z434. So another poll question: to what degree has your workplace implemented collaborative applications that involve collaborative tasks? And for those of you that are newer and are not sure what that is, we will talk about that later on. But if you can take a minute and respond to the poll, that would be great. Okay, so we're getting our responses coming in. So a few of you, about 10%, have incorporated multiple collaborative robotic applications. About 44% have incorporated one or two collaborative robotic applications, and a good number of you have not yet or have not implemented any collaborative robot applications. So why do we ask this question? The main reason is as you'll see when I get into the content, the new Z434 does include and has implemented a significant amount of guidance with respect to collaborative applications. And we will talk about what collaborative applications are and what collaborative tasks are. But basically, collaborative tasks are tasks where humans and robots share the safeguarded space or work together within the safeguarded space in close proximity, including in some cases making contact with each other. Now, of course, the robot requires certain safety functions to do this. We will get into this a little bit later on in the presentation, but it is certainly a field of robotics that's has taken off, and we're seeing it more and more within workplaces. And the new CSA Z434 does provide significant guidance that did not exist in the previous version of Z434 with respect to collaborative tasks and collaborative applications. So stay tuned for that. So again, we said we're going to start off slowly. I wanted to highlight the fact that this latest edition of CSA Z434, which of course is the 2026 version, is the 4th edition of the standard. And on the slide, you can see the different editions. You can see that between the 3rd and the 4th edition, we have about 12 years that have passed. So the 2014 version was reaffirmed a number of times. But of course, with the development and release of the new ISO 10218 Part 1 and 2 last year, it was definitely time for Canada and numerous other countries to adopt the latest version of the international standard. So again, just for your information, we wanted to highlight the different editions. Okay, so it's important to note that CSA Z434, the new version 2026, is a full adoption of ISO 10218 2025 parts 1 and 2. And you're going to hear me mention this over and over again throughout the presentation. But again, for those of you that are newer, yes, we have adopted, just like we did previously with CSA Z434-14, we have adopted the international industrial robot standard, and that standard is ISO 10218 parts 1 and 2. Just please recall that ISO 10218 2025 1 and 2 was published last year back in February of 2025. Again, for those of you that are newer to robotics, Part 1 focuses on safety requirements for the industrial robot itself. I sometimes refer to it when I'm doing training or these sessions. Part 1 refers to sort of the off-the-shelf robot, if you will, whereas Part 2 focuses on the industrial robot application and robot cells. Both parts 1 and 2 are Type C standards, which are equipment-specific standards. Part 1 addresses the off-the-shelf robot. You'll probably notice the second point under Part 1 as a partly completed machine. What that means is the off-the-shelf robot is not a complete machine until it is actually integrated into the application, which is what Part 2 focuses on. It cannot actually execute any tasks. So again, Part 1 focuses on requirements related to the robot, including safe design, risk reduction measures, information for use in an industrial environment. Whereas, again, part 2 focuses on the application and the industrial robot cell. So again, in part 2, we take the off-the-shelf robot and we integrate it into the application. Right? And I know that's a review for some of you, but definitely worth mentioning and worth going over. So please note, just to be clear, the outgoing or withdrawn North American National Industrial Robot Standards. So in Canada, the previous version of the robot standard was CSA Z434 14. And that was a modified version of ISO 10218 2011 Part 1 and Part 2, and actually contained Canadian deviations. And there was quite a number of deviations which provided additional Canadian-specific information and user requirements. In the US, because I know probably some of your companies have locations or may have locations both in Canada and the US, the outgoing industrial robot standard in the US is the RA R1506 2012. In that case, that was a full adoption of ISO 10218 2011. In other words, there were no deviations included in it. But the old version of the US R1506 standard was the 2012 version. We already mentioned that the new and recently published version of Z434 is the 2026, and it was published again on in May of 2026. And in the US, the current version of the robot standard or the industrial robot standard is the A3 R1506 2025, which was published last year in October of 25. So if you recall, I mentioned ISO 10218 1 and 2. The newest version was published in February of 2025. The US adopted that international standard as the US national standard in October of 2025, and we now have also adopted it in Canada as of May 2026 as our Canadian national robot standard. Now, there are still a few deviations which are editorial in the Canadian standard, and some deviations related to Canadian specific references, but I want to emphasize that both Z434 26 and R1506 2025 are technically the same as ISO 10218 2025 parts 1 and 2. Okay, so technically there's no difference between the Canadian, US, and international standard. So I already mentioned, but again, we can recall that part 1 of CSA Z434 focuses on the robot. And really, it is intended for the robot manufacturer. So the robot manufacturer really needs to meet, if they want to claim compliance with the standard or with part 1 of the robot standard, again, the requirements in part 1 are really intended for the robot manufacturer. So think of your Fenix, your ABBs, KUKA, Nachi, UR, whoever. They're obviously going to be very interested in the requirements outlined in part 1. Whereas part 2 talks about the robot application and cell integration. So again, focuses on the application in the robot cell. And it is intended primarily for the robot integrator. So the robot integrator is that entity that takes the off-the-shelf robot and then integrates it into the application or the robot cell. Okay. Now, so no change there. Okay. The new Z434 still has a part 1 and a part 2. However, what is new is that both CSA Z434 and A3 R1506 have developed and added an additional part, which is really a new standard. So in Canada, we have a new part to the standard called CSA Z434.1. And in the US, they simply refer to it as Part 3. And this additional standard focuses on a piece that was, frankly, it was missing in previous versions of the standard. And it focuses on safety requirements related to the use of industrial robot cells. And this new standard, the CSA Z434.1, focuses on end user requirements. Okay, so that is a major development with this new standard. Previously, the standard, of course, addressed the robot application, and the integrator requirements, but really we didn't have very much for the end user. And just take note of the fact that this is one of the reasons why our previous, that our technical committee in Canada, CSA Z434, included Canadian deviations in the previous version of the Z434 standard, which was the 2014 version. It was actually to provide some of that end user requirement or end user guidance that really ISO standards do not focus on. ISO writes standards for robot manufacturers and robot integrators, but they do not really the ISO standards really do not speak to the end user. Of course, we know that in Canada and really in all of North America, health and safety legislation places the highest degree or the highest responsibility for safety on the employer or the workplace. So the technical committees in North America, being the US and Canadian technical committees, felt it was important to provide end user requirement and end user guidance. Hence the reason these two technical committees work together to develop Z434.1. And we'll take a bit of a look at what Z434.1 contains towards the end of this session. Now, I didn't want to get too far into the weeds, but I did want to just highlight some terms and definitions that are included in the new CSA Z434 and highlight some changes in some of these terms and definitions, which will provide context and understanding with the direction that this new standard has gone in. So the first term is the industrial environment. So the new Z434, just like previous version, focuses on robots operated in an industrial environment. There's no real change there. And of course, an industrial environment is a workplace where the public is restricted from access or not reasonably expected to be present for the intended tasks and robot applications. So we don't really expect the general public to be exposed to these robotic applications with respect to this standard and who these standards focus on. Now, the industrial robot, or the definition for industrial robot, remains mostly unchanged, but has been tweaked. So an industrial robot, again, this is a bit of review, I know for many of you, is an automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes, which can be either fixed in place, and then you see a ... And this is where the definition diverges between the previous and latest version of Z434. So previously, it said that industrial robots can either be fixed in place or mobile for use in automation applications in an industrial environment. That term mobile in the previous version of Z434 was a bit ambiguous. Does this mean that the robot has a 7th axis and is on some sort of a shuttle table? What does that actually mean, and what does the standard really focus on with respect to the robotic arm in a mobile setting? So the tweak to the definition, if you look at the 434.26 definition, it says that an industrial robot can be fixed in place or fixed to a mobile platform for use in automation applications and in an industrial environment. And that small change does provide a lot more clarity. Since or during the development of the Z434-26, there have been various industrial mobile robot or IMR standards that have been worked on. In the US, we have the R1508 series of industrial mobile robot standards that have been developed. There's a part 1 and a part 2 and a part 3 that will be coming out. The part 3 will be coming out later this year. And the industrial mobile robot standards talk about the mobile platform and the fact that you can have, with a particular type of industrial mobile robot, you can have a robot arm mounted on the platform. So that small change in the definition does provide clarity on what the Z434 standard focuses on. It focuses on the robot arm, and there are other standards that focus on IMRs or industrial mobile robots. So now what about the robot system? There has been a bit of a change in that definition as well, between the previous and the new version of Z434. So in Z434-14, the robot system was defined as a system comprising of an industrial robot, end effector, and any machinery, equipment, devices, or external axes or sensors supporting the robot performing its task. Well, you'll notice in the next slide that the definition has been, the scope of the definition of the robot system for Z434-26 has been reduced, so to speak, if you will. The robot system focuses on the industrial robot, end effectors, and any end effector sensors and equipment needed to support the end effector. So some of the other broader aspects that really speak to the robot application, which you will see in the next definition, used to be included in the definition for the robot system in Z434-14. So again, the term robot application, which is the next definition, is a new term. And it is defined as a machine comprising an industrial robot system. So again, we're incorporating the robot system, work pieces, task program, and machinery and equipment to support the application of intended tasks. So what I'm saying is this new definition of robot application is quite similar to the previous definition in Z434-14 of the robot system. So I wanted to highlight that difference because you'll notice that the new title of the Z434 standard uses the term robot application instead of robot system, which is why I felt it was important to highlight this and why this change occurred. The new title of our robot standard also includes the term robot cell, which goes one step further. It is defined as one or more robot applications, including any obstacle or object that has influence on the risk assessment of the intended use and associated safeguarded spaces and safeguards. So in a nutshell, the robot cell is basically a robot application or applications with the safeguards implemented. And so again, that is another term that you see, like I mentioned, in our new robot standard. It is the industrial robot application, and robot cell standard. The term robot system is no longer in the title of the standard, at least in our Canadian standard. Okay. This next slide here is just for visual purposes, and it shows the evolution of robot standards, both in the US on the left. The ANSI RIA. RIA used to be the Robotics Industries Association. You'll notice at the bottom of the left column, the most recent version of the US standard is ANSI A3 R1506/2025. Basically, RIA is now known as A3, the Association for Advancing Automation, and which is why they are a standards development organization, and this is the reason why the new standard is labeled as ANSI A3 instead of ANSI RIA. In the center column, you can see the progression of the international version of the industrial robot standard up to the current version, which is again the 2025 version of ISO 10218 1 and 2. And then on the far right are our 4 editions in Canada of the Z434 standard, up to and including the current version, again, CSA Z434 26. All right. So that pretty much covers sort of the general overview of the standards and gives some background on their development, the different versions, and what the different parts focus on. I'm just taking a quick peek at the chat. I'm not seeing any hands. Marius, I'm not sure if there's any questions in the chat.
Nothing for now.
Okay, good.
I think everybody's paying attention to the changes.
All right, good stuff. So I think we're going to move to the next topic where I highlight some of the changes in CSA Z434 26. Right. So the first thing I want to talk about, which is of course a very important topic related to machinery safety in general, but certainly with robotics and robotic applications. Something that hasn't changed is that a risk assessment is still required in both Part 1 and Part 2 of the standard. Now, in Part 1, a risk assessment shall be performed for the robot that focuses on hazards and risk reduction measures related directly to the robot. Like we said, Part 1 focuses on the robot. Typically, the risk assessment will include some form of a failure mode and effects analysis that actually focuses on the design aspects and possible failure modes of the robot. So things like robot materials, strength, other areas like braking capabilities, lifting points of the robot, so on and so forth. So it really looks at the grassroots design requirements for the robot. One thing you'll notice, and that we're going to talk about more and in more depth later on in the presentation, is that in this latest version of Z434 26, minimum performance requirements for robot safety functions are prescribed. They are not risk assessment determined in Part 1. And you're going to see what that means when we come back to performance requirements and safety functions later on in the presentation. But I wanted to highlight this point in relation to the risk assessment for Part 1. So similarly, in Part 2, again, a risk assessment shall be performed for the robot application and the robot cell. Okay, so I mean, there's nothing new there. But what is new is that there are 2 options for determining performance level, the performance level of the safety functions related to the application. And basically, these 2 options are Part 2, similar to Part 1, provides required safety function performance levels for safety functions related to the application. So it's important to note we have safety functions related to the robot itself and that are built into the robot. But then once we integrate that robot into the application, there are going to be safety functions related to the overall application. So that jumping back and forth that I mentioned earlier between Part 1 and Part 2 is demonstrated right here. In Part 1, we have functional safety requirements that are prescribed for the robot itself. And in Part 2, we have prescribed functional safety requirements that can be incorporated into the robot application as one of the options for your the performance requirement for your safety functions. Now, there is another option in Part 2, which again is similar to what we used to have in part 2. The results of a comprehensive risk assessment can determine the performance requirement for safety functions related to the robot application, rather than using those prescribed performance levels that I mentioned as the first option. So we have these two options. We can either use the prescribed requirements in part 2, or we can follow the results of a risk assessment. So the risk assessment is required. I don't want you to think it's a choice between doing a risk assessment or not doing a risk assessment in part 2. Again, when it comes to the performance level of safety functions, we do have the option of using prescribed requirements that have been added into the new part 2 of Z434-26. So I hope all that's clear. I know it can get a bit confusing, but you can see that relationship between part 1 and part 2. Okay, and I think I'm seeing, is there a question? I just saw one pop up, Marius.
Yes. Kevin was asking if the previously Z434 specified the performance level and category. ISO only specified performance levels. Has this change aligned with the recent release?
In fact, the previous version did specify, and that's definitely a question I can take right now. And again, you're going to see, we're going to talk more about this, but the previous version of the standard did provide a minimum requirement for the performance level of safety functions, including category structure, but it did provide the option of alternate performance level and category structures depending on the results of a risk assessment. So it provided minimum requirements plus, in addition, the option of performing a risk assessment. That there was some ambiguity there, and I'm going to talk more about that later on. But this question is actually a great segue into some of the slides I'm going to be focusing on later on. But I hope that answers the question. The previous standard did provide some minimum requirements. Those functional safety performance requirements are much clearer in the new standard. Okay. So thanks for the question.
We have another quick question.
Sure.
With this new release, does this have any effect on our PSR requirements?
So the PSR requirements, so this could be a longer discussion, but I'll try and answer it. I'll give a short answer and then we can revisit it offline if necessary. The PSR requirements, I'm kind of reading into the question and reading in between the lines. The standard, the CSA standards become effective in Canada, unless otherwise specified in the standard. They become effective once they're published. Okay, so for the sake of argument, what I'm going to say, if your equipment, if you had a PSR done on your equipment previously, and the PSR focused on standards that were in effect, so that were current and applicable at the time of the PSR, and there were no outstanding issues, so the PSR deemed the system or the application compliant, for lack of a better term, with the standard that was in effect at the time. It doesn't affect, this new standard doesn't affect things in that you have to go out and update everything on equipment that was already compliant with existing standards at the time. So I hope that answers the question, and I was kind of reading between the lines, so to speak, on what the question was actually asking. The PSR requirements, of course, are a legislated requirement, so there's no change. Of course, there's still PSRs are still required. They're still going to be triggered in the same way. They're still going to have the same 8 trigger items. But of course, as of May 1st, this new version of CSA Z434 is in effect. So this would become now the current applicable standard for robotic applications in Canada. So I hope that answers the question. And like I said, please feel free to reach out to any of us, any of the specialized consultants at WSPS that deal with pre-start reviews if you need more guidance. And certainly your pre-start providers can provide, definitive guidance on this topic as well.
Thank you, Rob.
Okay. So I talked a little bit about some of the changes with respect to the risk assessment. I mean, the big takeaway there was that risk assessments are still required for both Part 1 and Part 2, but I highlighted some of the changes in Z43426. What I'd like to do now is just summarize some of the other changes that you will find in the new CSA Z43426. And for those of you that plan on purchasing the standard or maybe already have some kind of viewing subscription of the standard with CSA, you will find a summary of the changes in both Part 1 and Part 2 of CSA Z43426 in the foreword of both Part 1 and Part 2. And I've just summarized these here, and we will go into a little bit more depth with some of these, not all of them, in the upcoming slides. So in Part 1, we have additional requirements for the design of, yes, the robot itself, because Part 1 focuses on the robot. So things like robot position holding requirements without power. There's a lot more guidance provided on position holding requirements when power is interrupted to the robot actuators. And really what it speaks to is the reliability of that hold position or that stationary position of the robot. And there has been some clarification and additional guidance provided with the braking or position holding capability of the robot that have been outlined in Part 1. Another change that you're going to find in Part 1 is mode requirements. So automatic and manual mode, or what we sometimes refer to as teach mode. So there's some highlighted information. I don't get too far into that in this session, but please make a note of it, and you're definitely going to want to zero in on that. In both Part 1 and Part 2, we have clarification of requirements for functional safety and those performance level for those safety functions related to both the robot itself and robot applications. So we kind of talked about that a little bit with respect to risk assessments. We're going to take a little bit of a closer look at that in a few minutes. Another change in Part 1, this is a fairly significant change, the introduction of robot classes, Class 1 and Class 2 robots. And again, still related to functional safety requirements as they relate to Class 1 and Class 2 robots. We'll look at that more closely again in a few minutes. Another change in Part 1 is test methodology to determine the maximum force per manipulator, or to verify the maximum force per manipulator for Class 1 robots. So again, with the introduction of robot classes, have come some test methodologies in Part 1 for verifying that a class robot meets the Class 1 criteria. Another Part 1 and Part 2 change is added requirements for cybersecurity. So not a ton of information because there are other standards that focus on cybersecurity and that Parts 1 and Part 2 point you to, but there is an added requirement to the new Z434 standard with respect to a cybersecurity threat assessment for both the robot and the robot application, right? To prevent hacking of robots that operate through or on on networks. Okay, so we want to prevent hacking and outside influences taking control of our equipment and creating unsafe situations potentially. Another change in Part 1 and Part 2. So the incorporation of safety requirements for industrial robots intended for collaborative applications, which I mentioned at the beginning. And I have a bit of a typo there. Just notice collaborative applications and collaborative applications. It should be for collaborative tasks and collaborative applications. My apologies there. So lots of information added to both Part 1 and Part 2 with respect to collaborative capabilities and collaborative applications. And we'll talk about those in a few minutes. And then the last one, or at least the last one that I'm going to touch on is the addition of risk estimation parameters specifically focused on robot applications. So I mentioned in part 2 that, of course, the robot application requires a risk assessment. Part 2 has added robotic application specific risk estimation parameters. Because the standard, both part 1 and part 2 are type C standard, the technical committee of ISO, ISO Working Group 3, which worked on ISO 10218, parts 1 and 2, felt it was necessary to add some risk estimation parameters specifically focused on robotic applications, right? So that's just a highlight, okay? And you will find these in the foreword of both parts 1 and 2 of the new standard. So I just mentioned it. One new addition to both part 1 and part 2 is that a cybersecurity threat assessment shall be conducted. Cybersecurity measures for threats related to safety risks are to be implemented, which is the reason why we do the threat assessment. We want to ensure that unauthorized access is prevented to the robot control system, plus its hardware, software, and application software, and any related configuration data. So the bottom line here is we want to prevent outside influences from gaining control to our robot and, of course, our robot applications. And you can see that I've highlighted in the last 2 points an IEC technical specification and an IEC standard that focus more on cybersecurity risk assessments. Okay, so we don't get too much further into it than this for this presentation, but you are going to notice that many updated machine safety and robotic safety standards are going to include a requirement for a cybersecurity threat assessment. Okay. So let's continue looking at an overview of some of the changes. So there has been a change in part 2 with, in both parts 1 and part 2 with respect to high-speed manual mode, which some of you know as high-speed teach, or sometimes referred to as T2 on some robot controllers. So the robot may have a high-speed manual mode, which high-speed manual mode is defined as robot speeds greater than 250 millimeters per second. I underlined the word may because it is an optional feature. By default, the robot manufacturer does not need to provide a high-speed manual mode or a high-speed teach mode, but it can be requested by the purchaser of the robot. So again, there's really no change there from CSA Z434 14. The change comes in that in part 2 with regards to the application. So when high-speed manual mode is provided, the active safeguarding during high-speed manual mode shall provide the same degree of risk reduction as the active safeguarding when the robot is in automatic mode. So automatic mode is the automatic execution of the task program. So when the robot is, think of it as production mode. When high-speed manual mode is provided, one or more of the following need to be met. And these are the points at the bottom of the slide. So access to the hazards shall be prevented, or access to the hazards shall be detected and brought to a safe state, and or a protective stop of the hazards shall occur if access is required into the safeguarded space of the robot. And when perimeter guarding establishes the safeguarded space, entry in high-speed manual mode shall cause a protective stop of all hazards. Bottom line, we can no longer be inside the safeguarded space of the robot with the robot in manual high-speed mode. Either the interlocking function needs to prevent or drop the robot to reduce speed manual mode, which is less than or equal to 250 millimeters per second, or if you really need to teach or operate the robot in manual mode and you need to do that with the robot in high speed, it would have to be done from outside the safeguarded space. So lots of information there. I'm going to take a pause and just make sure there's no questions with regards to high-speed manual mode. And I know that many workplaces have already have policies, if they have industrial robots, not to allow high-speed teach within the safeguarded space. However, that feature could still be provided, and it was still possible to perform high-speed teach within the safeguarded space if the appropriate clearances were provided within the safeguarded space. Well, that is no longer the case in Z434-26. All right, high-speed manual mode is not going to be allowed within the safeguarded space any longer. Is that okay? No questions with regards to that?
No questions yet.
All right, we'll keep going then. So this next slide goes back to functional safety requirements and performance levels of safety functions. So the SRPCS, which stands for the safety-related parts of the control system, minimum safety performance requirement in the previous version of Z434 was a performance level D, structure category 3. This was for both the protective stop and for the emergency stop functions. In addition, in the previous version of Z434, I mentioned this already, a risk assessment could determine alternate performance requirements. Now, it was felt that there was a lack of clarity, or if you will, some ambiguity with respect to performance requirements for specific robot safety functions in the previous version of the robot standard. Also, since CSA Z434 and ISO 10218 are Type C standards, equipment specific, it was felt that increased clarity was needed for performance levels of specific robot safety functions for both the robot and the robot application. So this is the reason why these additional requirements and additional guidance that are much more specific have been added to Part 1 and Part 2 of Z434. So another big change in the new Z434 standard, in this case in Part 1, is the introduction of robot classes. We have a Class 1 and a Class 2 that have been introduced, and you can see the criteria for both Class 1 and Class 2. For Class 1, the robot mass cannot exceed 10 kilograms. The maximum force cannot exceed 50 newtons, and the maximum speed cannot exceed 250 millimeters per second. If any of these criteria are exceeded, then the robot would be deemed a Class 2. Now, it is also important to note that for a robot manufacturer to deem a robot a Class 1, they would have to carry out testing, and this is a normative requirement. And really this is highlighted in the last point on this slide, that testing must be carried out by the robot manufacturer in order to classify a robot as Class 1. And this can be found in Part 1, Annex E. And it is a normative annex, which means it is a requirement for compliance, as opposed to being an informative annex, which is just intended to provide guidance. So these are very new concepts in the new Z434 standard. And there are functional safety implications related, as you can imagine, related to Class 1 versus Class 2 robots, which we're going to look at in the next few slides. So for Class 1 robots, the functional safety performance and other requirements include a reduced functional safety performance requirement for Class 1 robots due to their reduced capabilities and the fact that they pose a lower risk. The minimum requirement for class 1 for class 1 robot safety functions are performance level B or SIL 1. And this is highlighted in part 1 Annex C. And I know you're not going to remember all of these different parts, but just for context, I'm mentioning the where in the standard, in the new standard, some of this information is found. Also, class 1 robots, because of the lower risk related to them, do not require a 3-position enabling device integrated into their teach or control pendant if, based on a risk assessment, the foreseeable robot tasks like troubleshooting and maintenance and so forth can be performed safely without an enabling device. In other words, the risk assessment indicates that the risk is low or negligible, so to speak. However, the robot manufacturer must provide safety inputs for the integration of a 3-position enabling device if some of these tasks related to use of the teach pendant and the enabling device are a higher risk. So the robots do have to have the capability of being able to integrate a safety rated 3-position enabling device, but they don't need to have one if the tasks related to the robot are lower risk. So I hope that's clear. And again, any robot for which testing is not conducted to validate class 1, and specifically the force output related to class 1 robots, so that 50 newtons or less, will be classified as class 2. Did I see a question, Marius?
Yes, there's a quick question related to the mass of the previous slide.
Yeah.
If the mass is related to the payload, including the end effector for the classification of the robots. So
yeah,
is the mass including the end effector?
You know what? I think I have to. I believe it does include the mass, but Marius, maybe we can just mark that. We can highlight that, and I can verify that.
That's what I was doing in the background.
Yeah.
But I think it does includes the end effector and the payload.
Yeah. I'm pretty sure it does include the payload, and certainly with a 10-kilogram robot. And actually, I'm going to recant on that and more definitively respond. Kind of put me on the spot here. That it does include the payload. As you know, robots are rated based on their payload capability. So yeah, that 10-kilogram would include the payload, but I will double check that just to make sure, and we can get back to who asked the question, Marius? Sorry, I'd have to just take a look at my chat.
Taylor Wood.
Yeah, okay. So Taylor, I'll verify that just to make sure, but I'm fairly certain it does include the payload of the robot.
Thank you.
Yeah, which would include the end of arm tooling and the part. Okay, which I know is not a lot, but hence the low risk related to the class 1 robot. Okay. So let's take a look at class 2 robots. And again, anything that's not rated a class 1 would or categorized as a class 1 would be categorized as a class 2. Now, the minimum functional safety performance requirement for class 2 robots is either a PLD with category 3 structure, or a SIL 2 with hardware fault tolerance structure equal to 1, or a PLD or SIL 2 performance level with a probability of dangerous failures per hour of less than 4.43 times 10 to the negative 7. And so again, I'm not going to get too far into functional safety requirements, but this last point that is or boxed in red is a new requirement that has been added to the CSA Z434 standard. Basically, what it means is you don't necessarily have to have a category 3 or hardware fault tolerance of 1 structure if you can achieve with the various components that make up your safety function, if you can achieve a probability of dangerous failures per hour that is less than this value of 4.43 times 10 to the negative 7, you can actually avoid having to use a category 3 or hardware fault tolerance of 1. Okay, so it is a new requirement that has been added. This really tells us that if you are following the previous version of the standard and your robots met the minimum performance requirement of PLD, Cat3, or SIL2 with an HFT of 1, you're going to be fine with this new robot standard as well. But with electronic systems, different approaches, different ways of achieving performance levels are now possible, which is the reason why this additional criteria has been added. Okay. I also want to highlight that for Class 2 robots, in Part 1, Annex C, there are a couple of tables that have been added or included. They're referred to as Table C1 and C2. Table C1 are robot safety functions that must meet the minimum performance requirements of either a PLD Cat3 or a SIL2 with a hardware fault tolerance of 1, or a PFH of less than 4.43 times 10 to the negative 7, what we just looked at in the previous slide. These are, of course, your more critical safety functions related to the robot, such as interlocking functions, protective stop, mode activation, software-based limiting, which limits the reach of your robot, which limits the reach of your robot, for example, to prevent the robot from making contact with your perimeter guarding. So these are some of the more critical, and there's a whole list in Table C1 of Part 1. So these more critical safety functions, if you will, have to meet the higher performance level requirement. But again, these are outlined very specifically. So there's much less ambiguity on what these safety functions are and what performance level they need to meet. So similarly, there's a Table C2 in Part 1 of Annex C, and it provides alternate minimum functional safety performance possibilities for specific safety functions that you could refer to as less critical. That might not be the best way of characterizing them, but safety functions that the technical committee has deemed can have a lower performance level. So things like your emergency stop function. So the minimum performance requirement for emergency stop functions in the new Z434 is PLC SIL1, which aligns it with other standards, including ISO 13850, which is an emergency stop standard. You have a normal stop, which can be a minimum performance level B. A reset function, which can be a performance level B. And then again, the table includes other safety functions, which can have a lower functional safety performance level. So again, I want to stress at this point that there's no provision in Part 1 to use a risk assessment to justify a lower performance requirement than specified in Annex C. So we really need to pay attention. By we, I mean the robot manufacturer needs to really pay attention to Table C1 and C2 because these are prescribed requirements. Okay, or prescribed performance levels for the different safety functions. Right. So I'm not seeing any questions. I'll keep going. So what about Part 2? So similarly, Part 2 has added some additional functional safety performance guidance for the application. And like I mentioned earlier, there are safety functions that are built right into the robot itself. And then you're going to have obviously safety functions that are related to the overall robot application. So part 2 is a little bit different, and in some ways similar to the previous version of Z434 2014, in that there are 2 approaches for the integrator to determine the performance of each required safety function. So again, there's an Annex C in part 2 that also has a table C1, which lists safety functions, that lists the performance level for safety functions related to the robot application. However, there is the option, so option 2 is to perform a risk assessment and determine the functional safety performance for the application-related safety functions based on the result of the risk assessment. So when I talk about safety functions related to the application, it could be, again, a light curtain safety function. It could be a safety function related to other safeguarding devices implemented into the application, as opposed to some of the safety functions related to the robot itself, which part 1 focuses on. So things like, I mentioned a few examples earlier. So what are some of those safety functions related directly to the robot? So safety software limits, monitored speed capability, monitored stop capability. So these are some safety functions, again, related directly to the robot. So again, we have guidance in both part 1 and part 2 related to determining the performance level for those safety functions. Just remember that in part 1, they're prescribed. In part 2, there are minimum requirements that are listed that can be followed, or a risk assessment could be performed to determine alternate performance levels for safety functions for the application. Okay? And that's basically what we're talking about here. And of course, the prescribed performance level for safety functions in part 2, as you can imagine, align with part 1. So it's the PLD category 3, SIL2 with a hardware fault tolerance of 1, or the probability of dangerous failures per hour being less than 4.43 to the -7. And again, as I mentioned, this last criteria, this last sort of requirement that's been added for performance requirements of safety functions in part 2, like part 1, has been added because newer electronic based systems can achieve this very low probability of dangerous failures per hour with some of these newer electronic system technologies. Whereas with your mechanical or electromechanical based safety functions, again, you really can't achieve PFH of less than 4.43 times 10 to the -7 because, again, you need to achieve a very high diagnostic coverage and a very high mean time to dangerous failure for the safety function. So really, this new criteria that's been added both in part 1 and part 2 is really for electronic systems or subsystems, okay? So again, I'll take a quick pause. I'm not sure if there's any questions about functional safety.
Not yet, no.
But we're going to move off that topic and move on to stop functions. So there's a lot that's the same in the new Z434 as the previous version. So of course, as you can imagine, the new Z434 requires that there be an emergency stop function, which is a function intended to avert or reduce existing hazards, as well as a protective stop function, which is a function intended to stop the machine in response to a safety-related event. And of course, our emergency stop devices are integrated into the emergency stop function, and our other safeguarding devices like light curtains, safety interlock switches, and so forth are integrated into the protective stop function. Something that is new in the new CSA Z434 in relation to stop function is the requirement to include a normal stop function, which is a function intended to stop a machine as part of a routine operation. It has a lower performance requirement, so it's a minimum performance level B. And really, the normal stop is intended for your, think of your day-to-day stopping of the robot application or the robot as part of normal operations. Of course, we don't want to hit an e-stop every time we want to stop the application under normal operation, because of course the emergency stop can be very much harder to recover from. And just let's say it's a type of stop that's much harsher on the system in that it may not retain some of the logic, some of the positioning logic related to the robot and the application and so forth. The big reason why, oh, go ahead, Marius.
Sorry for interrupting, Rob. We have a quick question from Diana. She's asking if the normal stop function is intended for minor servicing tasks.
I would have to say, without going too far into that very important topic and very relevant topic, definitely not. The normal stop is not intended to be used for minor servicing tasks. It is meant to stop the robot and once integrated into the application itself. Think of the end of a shift and stopping your application once the operator is ready to leave at the end of the shift. It's a way of stopping the application. Certainly for minor servicing tasks, again, without going too far down that discussion, your first and default approach for controlling hazardous energy should be full lockout. And where justified and properly vetted based on CSA Z434 standard and some of the criteria outlined in the lockout standard, you would want to use you would want to be protected by a safeguarding device that has a high performance level and category structure, because again, we want to make sure we're keeping people safe when they're performing those minor servicing tasks with respect to exposure to hazardous energy. So I hope that answers the question, Diana. So the answer is, I know it was long-winded. Definitely not. The normal stop is not intended for minor servicing tasks. And you can see, right, it has a lower minimum performance requirement even than the e-stop and certainly than the protective stop. Again, the reason for the answer there. Why was the normal stop added? Just as an FYI to everyone, which again is not maybe a big issue so much in Canada, but when the ISO 10218 latest version was being developed, they wanted it to be what is referred to as a harmonized standard. And in other words, which means it needed to be harmonized with the EU Machinery Directive. And the EU Machinery Directive does include a requirement for a normal stop in conjunction with the other stop functions. So this is the reason, one of the big reasons why this was added to the standard. Not to make everyone's life difficult, but really to try and make this a harmonized standard internationally. Okay. Okay, so that's really all I wanted to talk about with respect to stop functions. So we're in the last 15 minutes of the session. We're getting into another big topic, but I'm going to try and take us through it maybe a little more quickly to try and maybe take a few questions in the last few minutes of our time together. The next thing I want to talk about is collaborative capabilities with respect to part 1 and collaborative applications with respect to part 2. So part 1 talks about and has provided a lot more information with respect to collaborative capabilities. You will no longer find the term or see a definition in part 1 for collaborative robots. And we're trying to move the industry away, although it is a very ingrained term. We're trying to slowly move the industry away from the term cobots, because really there's no such thing as a collaborative robot or a cobot. They're all industrial robots, but industrial robots that are capable of collaborative tasks. So in other words, safeguarded space sharing with the human, will or have to consist of certain collaborative capabilities or safety functions. So a new term you're going to see in part 1 is the collaborative task. It is a portion of the robot sequence where both the robot application and operator are within the safeguarded space. Okay. When we talk about what those actual collaborative capabilities are, we refer to them as, and there are 3 in part 1, we refer to them as hand-guided control, speed and separation monitoring, and power and force limiting. Now, these used to be referred to as types of collaborative operations, but they're really not types of collaborative operations. These are actual collaborative capabilities that industrial robots have to be equipped with in order for them to be suitable for collaborative tasks. There used to be another collaborative capability included in the previous version of the standard called safety rated monitored stop. This has been removed in the new CSA Z434 and the reason for this is that what we used to refer to as safety rated monitored stop, which is now referred to more correctly as monitored standstill, is actually a safety function that is incorporated into the other collaborative safety functions or capabilities. In other words, hand-guided control, speed and separation monitoring, and power and force limiting. All 3 of those involve monitored standstill, the monitored standstill safety function. So it's really not a standalone safety function or collaborative capability on its own. Hence the reason why it is not listed separately as a collaborative capability or safety function. Okay, so that deals with the robot itself. What about the application? Again, a new term that you're going to find in Z434-26 Part 2 is the collaborative application, which are robot applications that contain one or more collaborative tasks, as you can imagine. Now, Part 2 provides guidance on risk reduction considerations for collaborative applications, not just the robot. So the risk assessment is required to determine protective measures to identify possible contact events between the human and the robot, and risk reduction measures to prevent quasi-static, which are crush hazards, and transient hazards, which are otherwise called impact hazards. Also, contact exposure to sensitive body regions, including skull, forehead, face, neck, eyes, and so forth, needs to be avoided. And where risk reduction cannot be practically achieved in the collaborative application, there may be a requirement to add traditional safeguards to prevent those contacts with sensitive areas. Okay, so these are just some things to think about when we're talking about collaborative applications. The risk assessment really has to focus on those contact events and interactions between the human and the robot. We can also have hybrid applications, which can include both collaborative and non-collaborative tasks. And the non-collaborative task would be more of your traditional tasks where your robot operates at the higher speeds, higher force and pressure outputs, and so forth. And in these types of hybrid applications, the transition point between the areas of where your collaborative tasks are being carried out and your non-collaborative tasks become very critical, need to be appropriately safeguarded, and definitely need to be focused on in the risk assessment. Just a bit more of an aside with power and force limiting collaborative applications, just to kind of highlight what we're seeing in the field. And unfortunately, I don't have too much time to spend on this, but collaborative robots are not inherently safe. So contrary to maybe some misconceptions that exist in in workplaces and in the field, they are not inherently safe. And collaborative applications may or may not require safeguarding. It all depends on if they are configured correctly. So please do not assume that collaborative applications automatically do not require safeguarding. Okay, I just want to highlight those two things. And please, if you need more guidance on this, please reach out to us. Or again, your pre-start providers that have experience with collaborative applications, because there is more guidance we can provide on this. Please also note that some of that significant additional information that you will find in part 2 with respect to collaborative applications is part 2 Annex M, table M2, which is a table of biomechanical force and pressure limits for 29 regions of the body that the robot cannot exceed. And the robot application cannot exceed in order to keep those interactions between human and robot low risk. All right. Also, Part 2 Annex N provides guidance on the validation methodologies for maximum force and pressures related to collaborative applications, and some guidance on the use of pressure and force measurement devices. So again, Annex N is an informative annex. It's intended to provide guidance, so it's not normative per se. But what is a requirement in Part 2 is that some form of verification and validation, i.e. testing of pressure and force outputs for power and force limiting collaborative applications is performed. So the validation of those power and force outputs for your collaborative capable robot and robot applications, they must be validated, and that is definitely a new requirement in Part 2 of the standard. Okay, so just some challenges with Annex M. Which body parts during the application are likely to be exposed to contact events? These need to be identified. How to avoid quasi-static contacts, which are crush contacts. How to reasonably prevent contact with sensitive areas of the body. How do you repeatedly and accurately measure force and pressures to validate application? So Annex N provides some of that guidance. And what happens when values in table M2 are exceeded? Sometimes force values might be exceeded. Sometimes pressure values are exceeded, depending on the application. In certain instances, you'll focus on force more. In certain instances, pressures are more critical. We can provide more guidance on that moving forward. Not a lot of time here, but I just wanted to highlight that. Okay. Now, the next couple of slides, I'm not going to spend very much time on at all. You can certainly have a look at these in your standard, but I just wanted to highlight the number of annexes in Part 2 and why the new Part 2 of Z434 2026 is so long, because there's been a lot of additional information from other technical specifications and technical reports added into Part 2, as you can see in Annex I, J, and Annex M. In Annex M, the information from the ISO technical specification 15066 for collaborative applications has actually been incorporated and made normative in Part 2 in what we call Annex M. Okay, so I just wanted to highlight that. So let's take a minute and talk about Z434.1. Not really much, again, in this session, but I wanted to highlight that, and I mentioned this at the beginning, there is a new part that has been added to the new Z434 standard. It's called Z434.1, and it focuses on end user requirements. The US has a similar third part, and they call it Part 3. Z434.1 focuses on design consideration, interaction with integrators, implementation of information from the integrator, so the information for use and how that should be implemented by the end user. Highlights training requirements, the requirement for a user risk assessment, so not just an integrator risk assessment, but a user risk assessment should be performed to make sure that the application meets incorporates the appropriate risk reduction measures and has achieved the appropriate risk reduction, and how to maintain acceptable risk. Okay. Upcoming technical report. Just FYI for everyone, ISO is working on a new technical report. It's called ISO TR 2218 Part 3. It is in the draft stage, and the idea of this new technical report will be to provide additional guidance. So we're not going to really have anything like this in Canada, but the idea of this new technical report is to provide guidance on the implementation of Part 2 of the new ISO 10218, which will, of course, help us with the implementation of the new Z434 2026 Part 2. So please stay tuned for that. And really, it contains examples, like sample applications and examples on some of the different topics contained in Part 2. So really, we're pretty much at the end of both close to our time and the session. Again, just a recap on this slide on some of the changes that we highlighted in the new Z434-26. Okay. Just another FYI slide for the group regarding some of the member benefits, of course, that all your companies are a part of, simply because of the fact that you pay WSIB premiums. That makes you a member of WSPS, and there are a number of free services and other services that you are entitled to. So please reach out to us for those. Okay. And yes, there is a lot of free stuff that we can help you with, where we can provide guidance. Here are some of the services, both training and consulting, that the machine and robotics safety portfolio provides to workplaces. I just want to highlight that we are working on a new robot safety course for the new CSA Z434 standard. We are working on this in conjunction with CSA, so it's a co-developed course, which is why we can call it a CSA course. And it's going to go into a lot more depth into a lot of these topics that I touched on today. Yeah, it'll be a lot more detailed, of course. Again, friendly reminder, if you would like to please fill out this demographic survey that the MLI TSD puts out, just to collect demographics information. And that's pretty much it for me. And I know I've used up all of our time, which I was hoping to have a couple of minutes left.
We have a quick question from Taylor,
Yes.
asking when would this new course Z434 be available for
Yeah,
training?
Yes, that's the $1 million question that I'm getting, since I'm one of the people working on it. Yeah, we're hoping that it's going to be the fall, Taylor. That's what we're targeting.
Thank you. And also a friendly reminder that we're going to have a lot more safety connections added to our database. So please tune in to WSPS.ca and see the communications on the new safety connections that we're going to bring. And they're related to lockout, tagout, other methods, and maybe materials for determining the criteria and selection methods and so on. So yeah, definitely something interesting in the future also for lockout, tagout, because I saw there was an interest in the chat.
And please, I just went back to the first slide. Feel free to take down my email address and feel free to reach out. Again, that's part of what we are mandated to do at WSPS. So I'm happy to have a virtual meeting with you. And in some cases, we can come out and visit you in person, depending on where you're located and so forth. It might not be myself. It could be other specialized consultants. A couple of them are in the session, including Marius. I know Mike Wilson's on the in the session as well, who's very knowledgeable. I think there are others that are part of our practice. Please reach out to us with any questions related to machine safety, robotic safety, PSRs, or any other topics related to machinery and robotic safety. We're happy to work with you and provide whatever guidance we can. And that's it. Thank you again for attending. I hope everyone has a great day, and hope to see or talk to you soon.
Thank you so much, everyone.
Take care, everyone.